All right, so now we're recording and I'm pretty sure, okay, I am sharing my screen. I have to follow an order, otherwise I'm lost. Okay. Before we can talk about pie charts and bash pie charts properly, let's talk about the quiz. So I've already taken a screenshot of this, so I want to bring it into our notes. Wait, wasn't that a pie chart, Emily? It sure was. My screenshot wasn't very good. Cut off quiz, but I think you know what I mean. Hopefully you're not too worried about the quiz. Came out of nowhere. But what I did was I gave a little block for quiz one, just so we get an understanding of what the quizzes will look like. And I didn't want to put all this in the same block as this week's material. So it's just underneath this week here. Okay, so you're going to do the quiz on your laptop. I guess what I should say here is make sure that it's charged. As you can probably tell, there aren't that many plugins. So it'd be really terrible if, 4 people had to be huddled down here to do their quiz. There's 2 there, 2 there. You know where the outlets are. Probably some over there, right? There aren't that many plugins, so make sure that your computer is charged, but you'll need to bring your laptop tomorrow. If you don't have a laptop, or maybe you forget it or whatever, you can borrow one from the library. I think they're free for the day. And then if you need it overnight, I think there's a charge. I think it might be $5 or something, but for us, it's just for the quiz. So you can just borrow it for the day. So you'll need a laptop, I guess, a charged laptop, ideally, because the quizzes are going to look like this. Here, of course, we'll be at 11, so it'll look different, but I just wanted you to have a feel of what it's going to look like. Okay. So it's going to be in the same format as assignment 2, 3, and 4. And all of those are on there. Okay. And I think I even said that here. The quiz questions will be very similar to the assignment questions that you've been working on. Right. And so assignment 2, assignment 3, and assignment 4. I know, rude, because that's the stuff that we're covering today. Although I have seen that some people have finished assignment 4 and already have 100%. So that's awesome. And you can do it, but we're going to go through it today. And together, I want to work through what I would consider the hardest question on assignment 4, right? Because we are just wrapping it up today and then quizzing on it tomorrow, right? And so I just want to work through one of the bigger ones together today. You'll have different numbers, but just so we can learn to read these problems. You're welcome to bring blank paper if you find that you need to kind of write stuff down on the side, but then your answers that are submitted in the quiz are what you'll have, right? There's no real written work for this quiz, so I'm not too worried about it. But if you do use scrap paper, I'll bring some scrap paper too, in case you find that, oh, I didn't bring any, I need some. So I'll have some for you as well. But if you do use scrap paper, you'll have to hand it in to me at the end of the quiz. That's just how it is. Okay. If you find that, oh, I did it right in my written work, this is more for later quizzes, right? But if you find that, oh, I did it right in my written work, but then for some reason I entered the wrong number or whatever, then you can let me know. And then when I have that written work, I can go back and I can adjust your grades. Okay. In general, I go through all the quiz questions or the quiz answers, and anything that's marked wrong, I just make sure that it's actually wrong and not just, you put a percentage sign in there when you shouldn't have or something silly like that. Okay, and so You have to be careful with rounding. For this first quiz, I'm a little bit more lenient on rounding. So if it's a rounding error, I'll adjust your grade after that as well. During the quiz, you're not gonna know if your answer is right or wrong. You'll be able to go back and change your answer if you want to, right? But it won't tell you if it's right or wrong until I think the end of class. I can't remember how I said it, but until the end of class, when everyone's finished the quiz, then you'll see your grade. But then because I do go through and I adjust things, if anything, you might get a slightly higher grade than what's shown, right? Especially if you've entered answers incorrectly, right? Because it's our first one, and I think that's really silly. If it's the right answer, you should have those marks. You can use any calculator. I don't really care. I think the course outline says non-programmable. I don't care because you're working on your computer. You could use R if you wanted to, right? If you end up wanting to use an online calculator for whatever reason, then since we're in here, just let me know and, hey, can I use an online calculator? Yeah, sure. So you'll be working here. I'll be at the back, eagle-eyeing it because it's not open book. But if you find that you need some sort of calculator, then that's totally fine. So that includes R or just an online calculator or whatever you want. Okay.
Question then. For in the assignments, there's a lot of calculate the standard deviation by hand or the IQR by hand.
So the median and the 5-number summary in general, you'll have to do by hand.
Okay.
But so then you should have some sort of calculator. I have a stack of random calculators that have piled up in my desk. I usually bring those in case you find that you need one and you didn't bring one. So pretty basic calculations, but yeah.
Throw in R, the information R and the output.
Yeah, but remember it marks it differently. But if you tell me that, then I would fix it later. But it assumes that you're doing it by hand. So just so. All right. Any formulas that you need for the mean or the standard deviation, for example, I'll give them to you if you need them. I kind of assume that you know how to calculate the mean, right? But and I'm not going to get you to calculate the standard deviation by hand. That's crazy. But if I change my mind between now and tomorrow, I'll give you the formula. No, I'm not going to do that. But just whatever, if you need a formula, notice that the bounds for the outliers is not in this list. You have to remember those. Okay. Q1 minus 1.5 times the interquartile range, Q3 plus 1.5 times the interquartile range. Oh, memorization. You get better at it. That's why you should practice it. Okay, good. Any other questions about the quiz tomorrow? So like I said, last day, you have to write it during class time, has to be here during the appropriate time. If you can't make it for whatever reason, I care about you. I don't care about your reason for missing it. I'm just going to shift the weight to the final exam, right? But also, like I said, you're always better off just writing it, even if it doesn't go so well. If you improve, so if the final exam is better, I'll just pretend that you didn't write it and shift it to the final. Okay. All right. So, and I think what I'm meant to put here is that there are 15 questions. Don't get too hung up on that. That doesn't mean anything. In the assignments, you've seen that there are very quick questions and there are very long questions. Of course, it's a mix of that, but just so that you kind of know, there's about 15 questions. There are 15 questions. I usually throw a bonus question on there. Oh, there's a fly in here. So that's not one of the 15. All right. So that's everything you'll need to know for the quiz. No, just kidding. It's all outlined there. All right. So today we're wrapping up chapter 2, categorical data. So we've spent a lot of time talking about numerical data, of course. There's a lot of things that we can do. For categorical data, you'll see there's not a lot that we can do. We can basically make a table of the counts, and we can make a bar chart to visualize the counts. And that's pretty much it. There's some fluff, but in general, that's pretty well all we can do for categorical data in this course. Why did she say it like that? Well, you'll see in Stat 240. Why did she specify? In this course, this is all we do. So I think it's called section 2.2. I think it's called considering categorical data, but we're basically summarizing categorical data. Without using the word categories, it's really hard to describe what categorical data is, right? But it's data that can be grouped. So information that can be grouped into distinct and finite groups. Okay. So categorical data is data that can be grouped. I just realized that I use data, whereas before I was probably calling them variables, right? But a variable is a column in your data set, and then data is usually used to talk about the same column or a column in your data set. Okay. Maybe I'll say here categorical data / variables. Or variable. Doesn't really jive, but just in case you're thrown by that. So we have groups, and we'll have some counts in each group. So each group or category will have a count. Usually, we're going to summarize this by making a table, right? So if I have category A, B, and C, usually I use these generic categories, A, B, C, D, E, F, that kind of thing. Just in the beginning, it's probably a little bit annoying, but you'll see the benefit later on. Because then you can say, okay, well, if we're talking about the type of car, right? Honda, Ford, and then I blanked this morning and I'm still blanking. GMC, I don't know. Type of car, right? We can categorize them. There are a finite number of types of cars, finite number of groups, right? Could even do something weird like Honda, Ford, other. That works. So usually we have the count. Can talk about the raw count. Right? Just if I looked at 30 cars, then maybe I had 14, 10, and 6. I looked at 30 cars total, and here are the raw counts in each of these categories. Raw counts, like 6 out of 30, that's really hard for our brains to kind of understand, right? We can compare 6 to 10 to 14, but then when we look at it overall as out of 30, that's harder for our brains to do. So for that reason, we usually report the proportion instead, or potentially alongside the counts. A proportion, right, would be something like 14 out of 30. So now what proportion was in group A? Well, that's 14 out of 30, which is approximately 0.467. Just rounding to 3 decimal places. For group B, it's 10 out of 30, which is roughly 0.333. Don't worry, I have these written down already. But this morning I was doing it all. But then I get to come in here and act like the hero. Emily, my hero. 6 out of 30. 0.200. Notice that I typically like to match the number of decimal places. That's just kind of me being a little bit obsessive. The total proportion is 1, of course. So here, I want to make a note about the proportions. So we often use proportion, or we often convert the raw counts. Convert the raw counts to proportions. Now, one thing that I want to bring up, it's not so important for this section, but in the next chapter, it's going to be really important that we keep track of what I call the 3 Ps, which are proportions, probabilities, and percentages. And just remember that they're all the same. They're essentially the same. Okay, so just as a quick note here. A proportion is a probability. I've avoided that word because I'm saving it, but of course that is something we're going to have to talk about, right? Probabilities. And I say approximately equal to a percentage, right? Because I think our minds have already done the conversion to percentages from the proportions, right? 46.7%, 33.3%, 20%, but we're multiplying by 100. So that's why it's approximately equal to the percentages. Right. So I call these the 3 Ps. The 3 Ps are equivalent or roughly equivalent, right, with the percentage. But I find that we're usually pretty comfortable with that, saying that they're equivalent. And we don't have a hard time converting proportions to percentages. And usually if we're talking to a client, right, we would talk in percentages, but any sort of math we do is going to be with the proportion, right? Because percentages aren't anything. Okay. Something I wanted to add there, but I can't think of it. That's okay. Oh, yes, I can. Yes, I can. Proportions have to be between 0 and 1. Proportions are between 0 and 1. Okay. Mostly because they have to add to one. Right? If you've considered all the categories, then all the proportions should add to 1. All right, now on to my pie chart hating rant. No, I don't hate pie charts. Well, I don't like them. To visualize categorical data, right? So to summarize it, we use a table, right? To visualize the data, we're going to use bar charts, okay, or bar graphs. You can use charts and graphs interchangeably, but to visualize categorical data, we should use bar charts. Oops. Bar charts or bar graphs. To add more confusion, it can be 1 word or 2 words. Oops. Here's where I'm going to say you could also use pie charts. And I have had clients in the past who all they want are pie charts. Of course, you're going to give it to them, right? You might tell them that, oh, I prefer to use bar charts for this reason or that reason. They don't care. They want pie charts. Slave to the man, you know. Pie charts can also be used to visualize categorical data. I know what you're thinking. What does she have against pie charts? I'm going to tell you. No, I'm going to show you. Pie charts can also be used to visualize. But it's often difficult for our brains to distinguish between the sizes of the slices of pie, right? Especially if they're very close. And there have been studies done on, you know, are we able to see those differences easily? And in general, the general population, no, we can't really distinguish the difference between a slice this size and a slice this size, right? So, but it is often difficult to distinguish between the sizes of the slices. Say that 3 times fast. Between the sizes of the slices. It's going to end up being slices of the slices. Okay, so I've got just some basic example, just generic pie chart here. Stole this from the textbook, of course. Of course. Why would that be, of course? That's where I steal everything from. These, I think this example is talking about cylinders in a car, 4, 6, or 8 cylinders. And so here, these are the number of cylinders in a car. All right. You collect a random sample of cars and you see how many cylinders there are. There's either 4, 6, or 8. So despite those being numbers, right, those are categories, right? Are you a 4-cylinder car? Are you a 6-cylinder car? Are you an 8-cylinder car? Right, and so 4, 6, or 8. Okay. These numbers represent categories. in the beginning, that can be really confusing, right? You see numbers and you want to treat it as a numerical variable, but then it's not until you read deeper and you go, hey, I think that's actually categorical, right? And so when you first get your data, you're going to read through and identify those categorical variables, because we often store them as just numbers, right? But they are just categories. So if it helps you in your mind, you can replace A, B, C or something generic like that, right? So here, right, if you kind of test yourself, which slice is the smallest? I'd probably go for the blue one, right? 6, but I'm not entirely sure how it compares to 4. It's not, just obvious jumping off the page, obvious to me, right? And so that's the problem with pie charts. Okay. So I'll go back and I'll highlight that we should use bar charts. Now let's look at a bar chart and see the difference. So I've got a bar chart of the same data. Get a little bit smaller, right? And so here, this is the same data, just as a bar chart. And so immediately, not only do I see that the 6-cylinder group is smaller, right? I can rank these immediately with my eyes, right? But I can also see the frequency, right? So, and just like before with the table, you could have the raw count, so the frequencies, or you could have the proportions, which would just scale down the heights of these bars, right? Nothing would change. It would just scale down on a scale of 0 to 1, right? So in general, these can be, oh, got too many arrows, I think. The scale can either be raw counts or proportions. Same thing with the pie chart. Okay. The problem with the pie chart is, yes, you could go in and you can add what the count is for each of these, but isn't that the same information as a table? You just communicate that in a table, right? If someone has to go in and read it to figure out which one is the smallest, well, that's the same as using a table, right? And so that's why I and the online community hate pie charts, and pretty much all statisticians that there ever were, okay? Because you have to add more information when the whole goal of visualizing data is to not have to explain so much, to not have to, tell people, oh, this one is the smallest and this one's the middle and this one's the largest. Here, you can just see it with the bar charts. Okay. So here, in the bar chart, we can clearly see the different counts in the categories. We can clearly see the different counts in the categories. Okay. The only time that a pie chart is obvious is if there are only 2 outcomes, right? But if there are only 2 outcomes, if I tell you that, all right, 80% of flights are on time, well, then 20% are not on time. right? We already know that. I only need to give you one number and then we know the opposite, right? If half of the people working in the store smoke marijuana, then we know that half don't, right? That kind of thing. So that's where my half do, half don't video comes in. And that's just a reminder, if you find yourself making even a bar chart, of course, or a pie chart especially, of just two categories, you don't need to do that. You can just give the number, and that's even easier for the reader to absorb. I'm just gonna go with it. So the only time a pie chart is obvious is when there are only two categories. Is when there are only two categories. However, if there are only two categories, right, you should only report one of the values, whichever one you're interested in. However, if there are only two categories, we can communicate all the information with just one number. We can communicate all the information with just one number. Okay. For example, 80% of flights are on time. It's probably the opposite, but let's be nice. 80% of flights are on time. Right. That also means, therefore, are you guys okay with triple dot for therefore? It's shorthand for therefore. Therefore, 20% are not on time. Right, there's only two categories. That kind of thing. Right. 64% of the people surveyed said yes, then the others said no. In general, just as a heads up, in terms of terminology, if there are only two possible outcomes, we call it a binary situation, I guess. It's a binary outcome, but talk more about it. But let's just say here, in general, when there are only two possible outcomes, we call it a binary. Binary is 0, 1, right? So then you can attach a 1 to the thing that you're interested in, the outcome that you're interested in, and a 0 to whatever you're not interested in. We call it a binary I'll say situation. Binary meaning 0, 1. Yes, no, do, don't, on time, not on time. I only bring that up because we are going to talk about binary data, right? And so but we'll save that for chapter 3. I think it's 3 or 4. Uh-oh. Later, after quiz 1. So that's one categorical variable. what if we want to look at the relationship between two categorical variables, right? So that's what we did, sort of out of order, because for numerical data, right, we're pretty comfortable with scatter plots. And that's how we look at the relationship between two numerical variables. So now we're going to do the same thing, but for categorical variables. And on the assignment, there's a table, a two-way table or a contingency table that you have to work with. And that's what I want to go through with you guys together. But let's just jot down some stuff first. So to analyze the relationship between two categorical variables, to analyze the relationship between two categorical variables, we use a contingency table. We use a contingency table. Okay. Now, this is where you might find me annoying again, because I'm going to use just generic categories. But now we're talking about two variables. So variable one has categories A, B, C, and variable two has categories D, E, F. Okay, just generically. So here I've got A, B, C, and then I have D, E, oops. Give myself a little bit more room. D, E, F. Def. Well, these are the categories in variable one. Variable number one, how about that? And these are the categories, just generic categories in variable number two. Okay. And you know what, I'm going to bump this up just so I have one more. So I've got a page break here. That's what I'm dealing with. Okay. Because what do I want to do here? I want to add the totals, because often I'll be interested in what we call the marginal totals. Okay. Margins are things on the outside, right? And so marginal totals are the totals on the outside. And we can do that on this side as well. So if we add across here, then our first row total is the total in category A, right? So here's the total in A. If I add across the row of B, I don't care which category D, E, or F they're in, just are they in group B, then I have the total in B. And then, of course, the total in C. Down here, I'm going to have the overall total, right? So if I add up the total in A, B, and C, that's everyone that I surveyed, right? And so that's going to be my sample size. So here, this is the overall total, which is N, our sample size. Doing the same thing here, just for completeness, total E, total F. Okay. And then I'm just going to highlight that these totals are called marginal totals. Okay. So what we're going to be doing is we're going to figure out how can we use the counts that are in this table, because each intersection here, A and D is going to have some count, A and E is going to have some count, A and F is going to have some count, right? But it makes more sense if we have an example. How can we use these counts along with the marginal counts and the overall counts to find percentages or later probabilities, right? We'll call them probabilities, but they work the same way. But for this section, I avoid the word probability. And I only say percentage or proportion. Okay. All right. So what I wanted to do was just show you quickly, because assignment 4 is on the quiz, but it's also just itty bitty. It's only 4 questions. Here's a bar chart that you have to read. Another bar chart you have to read. This one I'm leaving for you to work on your own, because I find that the last question is the hardest. So that's the one that I want to go through a version with you guys, but you'll see they're very similar. Okay. So this is the one that we're going to work through together. Okay. You'll have different numbers, right? But I think it's really useful if you can kind of see how I pick apart the wording, because what's really frustrating about statistics in general is all the wording that we have to have a handle on, right? All these words, they mean something and they're all important.
C&D in that question were annoying.
Right?
It's like, what's the difference in these 2 sentences?
Exactly. That's what I'm gonna that's what I'm gonna kind of hold your hand through, because if you read them initially, there's seemingly no difference, but then when you look closer, and I did have someone come and ask me a question about one of the parts. I think it was yesterday, and I kind of clammed up because I'm like, there's one of these that I always get wrong, just like my gut reaction of how to solve it is wrong. So then I psych myself out. So that's why I want to show you guys just how to be really careful when reading these. Okay. So here's a screenshot that I took of a question. These numbers change, right? But get jiggy with it. So for my question, it says 1,240 randomly sampled, which tells me that this sample, I can assume it's representative of the population, right? It has nothing to do with this question, but in general, we have to keep track of that kind of stuff. 1,240 randomly sampled registered voters from Tampa, Florida were asked, whenever I say Tampa, I get this like American accent, Tampa, I don't know. Were asked if they thought workers who have illegally entered the US should be, 1, allowed to keep their jobs and apply for US citizenship, 2, allowed to keep their jobs as temporary guest workers, but not allowed to apply for US citizenship, or 3, lose their jobs and have to leave the country. The results of the survey by political ideology are shown below. Political ideology is how they vote. Throwing me off though, because the States is kind of notorious for only having 2 real parties, but whatever. Spices things up. It's a spice of life. For this example. Okay, so what do we have? Well, let's just highlight some of this information here. First off, right, 1240 is my sample size. Maybe I'll give myself a little bit of room. Right, N is 1240. So that's my sample size. That's good to know. And it also matches up down here, right? 1240. Let's call this variable 1, right? Which is kind of how they feel about citizenship. Let's boil it down that way. And then variable number 2 is also categorical, right? How do you vote? So this was at least 2 questions in the survey, right? How do you feel about people applying for citizenship, and how do you typically vote, right? And so we'll call this kind of variable number 1. And this would be variable number 2. Nothing changes if we switch the row and the column, right? You just have to link the numbers. So which one is 1 and which one is 2 doesn't matter. But here I'm just highlighting that there are 2 categorical variables. All right. There's also a sneak attack that I hadn't paid attention to, but round all answers to the nearest hundredth of a percent. What's a hundredth? That's 2 decimal places, right? 10th, 100th is 2 decimal places. That's sneaky. Good to know. You could have Googled your way there. What does that mean? 2 decimal places. Right. First decimal is 10th, 100th. Okay. All right. So just like in our kind of generic table up here, they've also calculated the totals for us. All right. So I think the first question kind of eases us into using this table, right? But it's really important that you read the question and just kind of go to the table and figure out, all right, what do they actually want from me here? Because it can get a little bit boggy. As any question, it starts off a little bit easier and then it gets harder as you go along. Or at least that's in my opinion. So here's our first question. What percent, okay, so that's important because then, okay, I need to convert it to a percentage, right? What percent of these Tampa, Florida voters identify themselves as conservatives? Yeah. So I understand that I'm gonna need to find, some percentage, which means I have to find a proportion, but what? All right. So here, when I read this, of the voters, let's just skip the Tampa, Florida, so my weird American accent doesn't come out. I've never lived in the States, but for some reason it just, I don't know, Tampa. Maybe it's an alter ego thing. My alter ego is from Tampa, maybe. So what percent of these voters? So it doesn't specify which voters, right? And so now that's my clue, or that will be my clue, that I'm going to be looking at the total voters, right? So of these total voters, what percent identify themselves as conservatives? So here, okay, political ideology, conservatives, moderate, general, or liberal, general, that makes no sense. Maybe I'll start my own party. The general party sounds a little iffy. Right, but we want to look at the total conservatives. Just as a reminder, just because I'm going to use the terminology. So the numerator is on top. And how I used to have to remember it is it's on top because it's numero uno. So it's the numerator, and then of course the other one is the denominator. You only need to memorize one to remember the other. That's not always the case, but it's usually the case. Then you have kind of a clue. All right, so the total number of conservatives here are 490. And then the total voters, the total sample size is 1240. So now, okay, this feels good. I'm gonna get a decimal answer, which I have jotted down here. I'm a stickler for these things. It doesn't really matter. I use an approximately equal. As soon as I go to decimal places, 0.395161293. I should have pretended I had that in my head. Should be about 0.395. Is that correct? My hero. As a percentage, we're pretty good at this, right? 39.52% to 2 decimal places, right? It asks for 2 decimal places. And just as a heads up, right? It's already got the percentage here. So don't include that. It's going to mark it wrong. Okay. It's going to say, you need to give me a number. But those are the kinds of things that I go back during the quiz. I know the quiz is kind of stressful, right? So if you did throw a little percentage in there, of course, I would give you that grade. I'll adjust it after. Okay. So like someone's starting a speech or something. All right, good. So let's do a couple more here. Couple more. We're going to do all of them. Okay. What percent of these voters are in favor of the citizenship option? Yeah. So now we're looking at just overall voters, and the citizenship option is option number 1, apply for citizenship. Okay. And so regardless of how people vote, a total of 393 out of 1240 are in favor of the citizenship option, which is exactly what we wanted. In terms of matching the sentence, kind of the same way that we did, right? Of these voters, which means the total voters goes in the denominator. What percent are in favor of the citizenship option? So total citizenship. I'm gonna grab those numbers. 393 over 1240. Which is roughly 0.3169354,839. I would encourage you to jot down all the decimal places, because then if you enter something incorrectly and it's part of your written work that you hand in, right? Then I can say, okay, well, you got it, you just entered it incorrectly, right? Especially if it's a rounding error, right? If you show me on your written work that you did it, then if you round it incorrectly, I can still give you the mark. for the first quiz, I'm not too concerned about proper rounding, but it is something that we should be working towards, right? So maybe kind of work on your rounding skills if they're not feeling 100%. 31.69. All right. Okay. So those two, I think, like I said last day, you could even approach these questions without knowing anything from today, categorical data, anything. I think if I handed you just this question, you could probably pick away at it and still do pretty well, right? Because it is just kind of linking up. Am I on C or D? C. Oh, I just wanted to skip C, you know? I almost did the whistling song from Jane the Virgin. You guys have watched it. It's a telenovela that mocks telenovelas. It's really funny. The name is kind of a turnoff. But anyways, there's like a really creepy whistling person. I almost did that one. Now my whistling's off. All right. What percent of these voters identify themselves as conservative and are in favor of the citizenship option? Okay. So before you jump ahead and just kind of say, okay, well, of these voters, right? You want to slow it down and read the entire blurb before you really land on something. And so what percent of the voters identify themselves as conservative? So now we're looking at a specific part of all the voters. So really what we're saying is how many of those who identify as conservatives are in favor of the citizenship option, right? So that's a little bit sneaky, right? And I'll highlight the and, right? And means that they have to be both conservative and in favor of the citizenship option. Okay. So in terms of what the denominator is, that's going to be the total that's where I led you, isn't it? The total, yeah. It's the total voters. Oh, dang it. But my blurb. It's a D that I'm thinking of. And that's the one that always trips me up. Oh man. It trips me up, it trips you up. It's not your fault. Okay, let's reread this. What percent of these voters, so it is still just all the voters. See, it's trippy. Identify themselves, and I even have the answers here. Isn't that so stupid? Identify themselves as conservatives and are, yeah, okay. It is the total voters, but the numerator is conservative and citizenship. I knew it. This morning when I didn't have anything to go off of, I did it just fine. Now when I have something. They have to be in this column, right? But they also have to be in favor of the citizenship. So that overlap is just the 59. And of the total voters, that's 59 over 1240. And that's correct. I just confirmed it. Oops. which is roughly 0.047580645516. 4.76%. Careful with the zeros. If you have a lot of zeros and you're not, paying attention when you multiply by 100 in your head, maybe actually do it on your calculator, just be sure. Because I've seen so many kind of unfortunate typos where you multiply by boop, boop, boop. Boop, boop. Done. Oh, I guess I moved the wrong way. Doom, doom. Yeah, you got to boop, boop. Boop, boop, boop. Your way in. Hey, yeah, I got to add it to my patent pending boop, boop, boop method. But that's just the boop, boop method. It's a whole different method. 2 boops. I can't believe I've never thought of that. It's going to be part of my repertoire now. You heard it here first. I stole it on September 22nd, 2022. All right. So here's the one where at first glance, it trips me up, but also these look the same, right? What percent of these voters who identify themselves as conservatives, there's the one that I was looking for, are also in favor of the citizenship option? So now it's this part who identify themselves are also in favor of the citizenship option, but that would defeat the purpose of the question, right? It's to get you to realize that, okay, things are weird or worded weirdly, weirdly worded.
Wouldn't that be the fault of the statistician? If you're to convey results to someone and you fumble up a bunch of words to make it confusing?
Yeah, usually we don't like to do that. But as teachers, we do to get you guys thinking. And you'll notice that the following ones, it's worded in an easier way. So it's just to highlight that it can be worded this weirdly. Gotta keep you on your toes. And this is just to practice reading the table, right? So I try not to pick confusing ones, but sometimes it's good. All right. So now they have to identify themselves as conservatives. I already did this blurb, but it didn't make sense. So now it'll make sense. They have to identify as conservatives, and then what proportion or what percentage. So here they have to be in the conservative total, right, which is 490. But then we want to know, okay, of these conservatives, what percentage are in favor of the citizenship option? So that would be the 59 out of 490. So now in the denominator, we have the total conservatives. I'll just highlight that to match it up. And then on the top, right, because we're only talking about the conservatives, well, then whoever is in favor of the citizenship option also has to be conservative. So then we would say conservative and citizenship. That and is the overlap, or the overlapping area, or the intersection, we'll call it. That is what it's called. 59 over 490. which is approximately 0.120408163. Or boop boop, 12.04%. Okay. I'd say that's the hardest one for sure. Because now E what percent of moderates? So here it's obvious, right? So out of all the moderates, who are in favor of the citizenship option, right? So now we do the same thing, right? So who are the moderates? Well, they're here, there are 492 of them. And how many of them are in favor of the citizenship option? Well, they have to be moderate and in favor of citizenship. So that's the 151. All right. So this is the nicer way to word, in my opinion, the same question, right? What percent of these guys are in favor of the citizenship option? But in terms of numerators and denominators, we have total moderates. They're total moderates. And the, oops, moderate and citizenship. Without scrolling up again, 151 over 492. Roughly 0.306910561. In all my years of teaching, since 2015 now, this is a lot of courses. I've always thought that someone should auto-tune me just reading all these decimal places. 0.306910561. Or maybe I should be going the ASMR route. 0.33069. 30.69. Right? So freaking good. Okay. Finally, now we're on a roll, but you'll want to be careful that you read these questions carefully. But I'm telling you, we're on a roll because they're all the same from here. What percent of liberals are in favor of the citizenship option? So of the liberals means total liberals. And same idea, right? What percentage of the liberals? Well, that means they have to be liberals and in favor of the citizenship option. So liberal and citizenship. Is 183 over 258. I'll go up there, but trust me. So again, we have the liberals, there's 258 and 183 of those liberals are in favor of the citizenship option. Which as a decimal, 0.70930232256, which is roughly 70.93%. The last part of this question introduces this idea of independent or dependent outcomes. Okay. And just kind of going with your gut, comparing 12%, because we've talked about, okay, if you are conservative, who's in favor of citizenship? We've been talking about the same thing all along, right? And so 12% versus 30% versus 70%, I think your gut reaction would or should be that those are not independent, right? How they feel about citizenship is not independent of how they vote, right? And vice versa. And so because those counts or those percentages are very different, right? That's why we would consider them dependent, since 12%, 30%, and 70% are so different from each other. Are so different from each other. Last thing I want to talk about, right? We did do that question. I hope that helps you. But to visualize categorical variables, especially if we have two categorical variables that we're looking at the same time, we can use a version of a bar chart, right? So either a stacked bar chart or a side-by-side bar chart. So here I'll say to visualize two categorical variables. We use a stacked bar chart or a side-by-side bar chart. And I've got so here we have a stacked bar chart where we might call it variable 1 and variable 2. Right? Variable 2 makes up portions of the bars, and of course, side-by-side bar charts just takes the bars and puts them individually, but in clusters. And then arguably most importantly, can't believe I didn't have it in there. How I Met Your Mother. Marshall has made a pie chart of his favorite bars and a bar chart. Hey, it's not getting bigger. And a bar chart of his favorite pies. Don't think about it too much because the data doesn't make sense. You can only have one favorite bar and only one favorite pie. How would you collect data? It would make sense if it said our favorite bars. What's your favorite bar? What's your favorite bar? What's your favorite bar? What's your favorite bar? Favorite pie, favorite pie. Anyways, with that, I release you. And I'll see you guys tomorrow for the quiz. Let me know if you have any questions though.